welcome to podcast.init. We're recording today on June 3rd, 2015. Your hosts, as usual, are Tobias Macy and Chris Patty. Today we're interviewing Fernando Perez and Brian Granger about IPython. You can follow us on iTunes, Stitcher, or TuneIn Radio. And please, give us feedback. You can leave us a review on iTunes or Stitcher, find us on Twitter, email us at hosts@podcastinit.com, or leave a comment on our show notes. Brian, Fernando, could you please introduce yourselves?
Sure. Thank you, folks, for having us. My name is Fernando Perez. I am a staff scientist at Lawrence Berkeley National Laboratory, a researcher at UC Berkeley, and I've been programming in Python since about 2001. I'm originally a particle physicist and applied mathematician, and these days a lot of what I do is really scientific open source software development around Python open source tools.
And I'm Brian Granger. I'm a physics professor at Cal Poly State University. It's a California State School on the central coast of California, about 3 hours south of the Bay Area. And I, too, am a physicist by training. Actually, Fernando and I were classmates in graduate school at the University of Colorado. And originally, I studied theoretical atomic, molecular, and optical physics. And I started with Python about, I guess it was around late 2002, 2003, a little bit after Fernando got into it.
Very cool. It's kind of amazing how strong the connection is between physics and computer science. I mean, it goes just kind of beyond, well, physicists use computers. I cannot tell you how many people in my career that I've encountered who have now basically given up physics and gone full-time computer science in one stripe or other, and really just kind of never looked back. There seems to be some sort of kindred souls thing going on between people who study physics and people who end up working in the tech industry. It's kind of interesting.
Yeah, and I'll say, too, that of the number of physicists who I've spoken with who did make the transition, or at least who do programming on a regular basis, a lot of them tend to use Python for whatever reason.
Yeah, I think it's got the amazing numerical capabilities that Python brings to the table. The other languages in this sphere kind of don't. So how did you folks get introduced to Python?
In my case, it was a suggestion actually from my office mate, another grad student in my case. I had a complicated stack of many programming languages that I used to run my simulations when I was in grad school. A lot of Perl to babysit supercomputing runs, a lot of awk, bash, sed, big C codes, GNU plot, IDL, Mathematica, and it was just a big complicated pile of codes. My office mate told me, hey, you should look into this Python language. It's kind of like Perl, but a lot simpler, and it can actually do a lot of numerics. It's also interactive. It's a lot simpler, and you might be able to replace many of those tools with something easier. And one day I looked at the stack of books I had on my desk, and I realized I was probably spending more time context switching between languages, between 6 or 7 languages, than actually getting any work done. And I realized maybe if I could replace 5 or 6 of those with just one and reduce that stack maybe to C for the high performance stuff and maybe Mathematica for the symbolics, I might actually get more work done. I mean, little did I think that I would just spend all my time writing Python tools, but it was true that I could actually replace those tools. And when I started learning Python, and I realized after about 24 hours of reading the Python tutorial that I was able to do in Python things that after a couple of years of writing heavy-duty Perl, I had no idea whether they were even possible or not. I realized that I would never write another line of Perl in my life. So after that, I just stopped, and I switched to Python, and I haven't stopped writing Python ever since.
And for me, I was actually, as a postdoc at the time, I came back to visit Boulder for a conference, and Fernando was still in Boulder. We met and had dinner, and I think it was probably about a year after you started working in Python, Fernando. And I remember Fernando telling me about Python with this great excitement, and I went back to my postdoc, and one afternoon sat down and, as an exercise, ported over one of my codes that I wrote as a grad student, looking at phase transitions and traffic flows. And I used that to learn the language, and I remember within a few hour period, it was all in one afternoon, getting everything working with a visualization and just being blown away at the ease of both learning it and also how the flexibility of the language allowed me to explore physical questions that wouldn't have even occurred to me because of the limitations of previously I was doing everything in C++. And I think seeing how that flexibility of the language had a direct impact on my ability to do science was a huge selling point. And over the next year and a half, I transitioned everything to Python.
It's very cool. It's really interesting how many scientists made that transition, made that leap from using Perl and, being productive with it, but to moving to Python and finding that their productivity just kind of exploded. I certainly saw that happening at the Human Genome Project when I was there a number of years back, and people definitely regarded Perl as the sort of legacy code base that they were trying to root out wherever they had the opportunity to, and everything new was being written in Python, and they were much happier with it.
Yeah.
So it sounds like the two of you knew each other before you got involved in the IPython project. Can you tell us a little bit about how you guys met?
Yeah. First day of grad school, actually. I remember we were both grad students, as Brian mentioned, in physics at CU Boulder, and sitting outside of the induction first-year grad students in Boulder, Colorado in 1996, and we've been friends ever since.
Great. So, for anyone who may not have heard of or used IPython, can you describe what it is?
Sure. IPython, back in the day, IPython started its life as an improved interactive shell for Python. I was a grad student in 2001, finishing my dissertation in particle physics in Boulder. And when at the behest of my office mate, I made the switch from Perl to Python, I realized, oh, wait a minute, I can actually use this thing and actually port to a lot of my workflow to this tool. And I can add numerics, and I can add plotting, and I can actually run a lot of my codes in this tool, but I need a better interactive environment. If I'm going to actually use this tool, I want to actually call my codes, I want to access the file system, I want tab completion, I want to run my scripts, I want to call out my figures, I want to actually run this as my environment. And I was used to tools like IDL, like Mathematica, like the Unix shell, and the interactive Python prompt is, compared to those, a very, very primitive tool. You can't do ls, you can't easily execute scripts and get really good tracebacks. You can't easily do good debugging. It just isn't a very sophisticated tool for that. And so obviously a grad student facing the option of either finishing a dissertation and writing it up or playing with code, the choice was easy. And so I dug into just building a better interactive shell, and thus was born IPython. Eventually my advisor kind of called me to order, and I went back to actually getting work done and graduated. But I put out the project out there. Initially it was just as all open source projects were born, kind of a one-man show for a while. It was just hosted on my webpage at the university. Then a company from Austin called Nthought offered me to put it up and host it. They were the company behind the SciPy library, to host it on their CVS repositories and to host a mailing list, which today they continue to host the mailing list for the project, to host it. And they were the people behind the nascent SciPy conferences and the scientific Python community. And so at that point, IPython sort of became a project that became one piece in the puzzle of scientific Python. And that's really what gave it life as a project and not just as a one-off exercise. If it had been just that, it probably would have died as just a one-off little interactive exercise. But because it became part of the workflow of other scientists, and other scientists began to contribute, and there was a conference that at the time was held every year at Caltech for scientists building SciPy and then Matplotlib and numerical computing tools and other tools for scientific computing, where we all congregated every year to build these tools. Then a community of users began to grow around not just IPython, but all of these tools where we collaborated, where we exchanged code, where we kind of worked together on trying to build an entire ecosystem of similarly developed open source tools for scientific computing around the Python language. And today, this is now a large effort. And in fact, it was I think at the second or third of those conferences where Brian and I started collaborating on IPython. Because, Brian and I, obviously, as we mentioned, we knew each other well, but we didn't start working on IPython at the very beginning, but it didn't take very long before we joined forces on the project. And it was precisely after me spending some time at one of these scientific Python conferences where we joined forces on the project.
Cool. That's very interesting to think of, particularly for anybody who uses IPython as part of their daily workflow, that if it weren't for Nthought offering to host the project, that it may not have continued to exist as we know it.
No, they were extremely generous, and we owe them a huge debt of gratitude because they provided support for the project at the very beginning and throughout the project, and they supported us at critical junctures. They actually funded Brian and I in 2010 at a critical point when we were developing the network protocols that actually allowed us to build the machinery that eventually led to the Qt console and the modern network architecture that supports the notebook, and then the multi-language, all of the modern features that really made possible kind of the renaissance of the project and its modern incarnation. And all of that was thanks to Nthought's support and financial contributions, and they've been a fantastic supporter of the community. They've supported the SciPy conference for many years, and so no, we owe them a huge debt of gratitude.
Another part of the history of the project that I was going to add is that, so Fernando and I started talking about some of the general ideas around interactive computing in 2005, and almost immediately we started to think about a notebook-like interface. And from 2005 until 2011, we actually made multiple attempts to build something like this. What was it, 4 or 5 attempts, Fernando?
Something like 5. I mean, in version 001 of the system, there's even references that we acknowledge to Mathematica and Maple, which are the originators of these interfaces, because that stuff was there from day zero even.
And it really took us all those different iterations of trying to build this, trying to understand the problem before we could do a good job of it. The other part was that a lot of the tools that we rely on, such as ZeroMQ, WebSockets, just didn't exist. And the notebook came about sort of over 3 summers in 2009, 10, and 11. We had funding in 2009 and 10 to refactor some of the old code base to get it ready to build this more network-based model. That was in 2009. And then in 2010, Fernando and I had the funding from Nthought to build the network architecture that enabled the Qt console. And then in 2010, we built on top of that and actually created the current iteration of the notebook that it continues to exist today.
Very cool. It struck me as you were talking about its genesis, how you as scientists had this need for a really great interactive environment, more than just sort of a prompt with better editing capabilities and things like that, because a lot of languages have that. But IPython, from my perspective, is really one of the crown jewels of the Python ecosystem. It's something and IPython and IPython Notebook are really kind of unique. And I realize Project Jupyter now encompasses other languages, but prior to that, there really was kind of nothing else like it that I've ever seen. And it really struck me that when other people may ask in other programming language communities, well, why should we? What's the gain for us in sort of doing the work to make our programming language more accessible or more desirable for science work? And I would point to that and say, this is something that grew out of a need that only scientists would really have to that extent. And now the rest of the community can benefit from it, because I'm not a scientist by any stretch of the imagination. I'm a tech worker and an information worker, I guess you'd say. And the things that I can do with IPython Notebook are just amazing from my limited perspective. So that's really cool. Thank you for telling us that story. How challenging was it to port IPython to Python 3?
So the simple answer for Fernando and I is that it was completely trivial, but that's because he and I didn't do it. We the summer of 2011, when we were building the current version of the notebook, Thomas Cloyver, who's now one of the core developers on the project, came and started to work on the Python 3 port. And he basically did the initial version of that single-handed and did an absolutely fantastic job with that. I would say it was not a trivial port in the sense that most of the weeds in porting to Python 3 have to do with strings and bytes and Unicode. And a lot of what IPython deals with are strings. Maybe it's a string of code or a file name or output. And so getting all of that working right was fairly non-trivial. In terms of the technical details, though, Thomas is our resident expert on that.
So what prompted I guess it wasn't a name change from IPython to Project Jupyter, but what prompted the creation of Project Jupyter as an extension to IPython? And were there any large changes associated with that in the IPython project itself?
Well, the prompting was kind of just a natural, gradual realization as we were building the machinery for the system, where we said, well, wait a minute, everything that we're doing here, when we looked at the protocol, when we looked at how the notebook and the console and the graphical console worked, and we said, wow, we're sending code, it's executed on the other side by a kernel, and it comes back, and the results come back. There's nothing in here that really is very specific about Python, other than at the other end, something takes that and happens to interpret that string as a blob of Python. It could be Perl, or it could be Ruby, or anything else for all it cares, right? What if we just abstract that over, and then all of a sudden we have basically a generic protocol to do interactive computing in any language, right? And what if we just if we do that, we'll have to do a little bit of work, because we've probably we've allowed kind of hidden assumptions about there being Python creep into the system. But if we do that, we probably fairly neat system that will allow us to reuse our architecture for multiple languages. And so once we kind of accepted to pay that price, it took some work, yes. Once we accepted to pay the price of abstracting over programming languages and to clean up any assumptions that we had about it being specific to the Python language, then we saw the benefit, because now all of a sudden people began actually implementing the backend for other languages. And so we actually went through our implementation. We cleaned things up, and we defined how to implement what we call the kernel for other languages. And people began implementing kernels for other programming languages, and we began seeing a Haskell kernel, and then a Ruby kernel, and then kernels for other languages. But then, obviously, the questions began appearing. Why is it called IPython if I'm running the Julia kernel? And obviously the Julia community wanted to call it iJulia, not IPython. Why do I have to run at the command line IPython -- Julia? Why do I have to run IPython -- profile Haskell? Right? And so we wanted to come up with a name that would really indicate that the project is language agnostic. We may have a reference implementation of the kernel that may still be in Python. Much like in the Python language, CPython happens to be the reference implementation of the language that happens to be written in C, but maybe at some point in the future, who knows, PyPy may become the reference implementation in a few years if at some point it becomes better. So for us, IPython now is the reference implementation of our protocols. It is our default kernel. It is the one that we develop, and a lot of our tools are developed in Python. But Jupyter represents this larger project, which is about interactive computing. The name is inspired by Julia, Python, and R, being the three, what we consider to be the three open languages of data science. That name came to us thinking actually about a conversation that I was having one evening at GitHub with folks who were arguing about basically those languages. And at one point I said, look, these languages are not enemies of each other. We shouldn't be arguing amongst ourselves. Julia, Python, and R are not enemies. The enemy is closed source science. These three languages are all partners in having open source tools for scientific research. But it's not an acronym. It really is meant to simply represent three languages that are part of an open source ecosystem for scientific computing and for computing in general. It doesn't have to be scientific research. It really is about interactive computing in general.
So I know that there's a project that I came across recently called the Beaker Notebook, which seems to be based largely on IPython and Project Jupyter, and it seems that it has the capability of executing multiple languages within the same notebook. Does Project Jupyter itself have that capability?
Well, the IPython kernel can actually execute multiple notebooks, multiple languages. If you prefix individual cells with %, for example, if you prefix a cell with %% Perl, that cell can execute in Ruby. If you prefix a cell with %, R, that cell can be in R. But that is specific to the IPython kernel. Our design is that the basic protocol refers to one kernel at a time. That kernel can define semantics, whatever semantics it wants. The IPython kernel happens to define very sophisticated semantics that can include more than one language. And in fact, the IPython kernel is capable of juggling in one process Python, Fortran-loaded code, Julia, R, Bash, Ruby, you name it. You can have 20 languages juggling back and forth in the same process. So we do have that capability within the IPython kernel. But the design of the protocol is that the notebook speaks to one kernel at a time.
Data scientists have adopted the use of IPython notebooks in their work at a large scale. What is it about notebooks that lend themselves to this particular problem domain?
I think it's the fact that in the context of data science, a lot of what you're trying to do is to combine. You're not trying to develop a software application. You're trying to understand a specific problem, typically centered around a specific data set, and you're trying to extract insight and communicate your understanding of that problem, your understanding of that insight, as a narrative. You're trying to extract that something out of it to communicate, and that communication may be to yourself because you're going to try to read that tomorrow, or to someone else, whether it's your partner, whether it's a client, whether it's scientific research that you're going to publish. The point is you're executing code, but that code is not to build software. That code is to grind through your data using your tools, your Python tools, your R tools, your Julia tools, to visualize your data, to apply an algorithm, to reduce your data, and then you will likely produce visualizations, summarize plots, produce summary statistics, and then typically you will actually introduce a narrative in English or in whatever language you speak. You will introduce human narrative, and it's the combination of that. It's the combination of the code, the results of the code, and the human narrative that put together constitutes the output that you care about. And that combination together really is it's sort of the perfect format for that, right? And the ability to have all of those things together and to share that as a compact unit that you can share with anyone, that you can send to someone and they can directly jump into it, they can re-execute, and that someone can be yourself 3 weeks from now or your colleague or your audience is sort of the perfect atomic unit. And I think that's why it has sort of caught on like wildfire. And as we said earlier, as Brian alluded to earlier, this is something that we fully acknowledge we did not invent, and we wanted it because we as grad students had used these tools in our own research, and we knew how powerful these ideas were.
So, yeah, as you mentioned, the capability of including a narrative in line with the processing and display of the data that you're talking about is very powerful, and I've actually seen a few instances, but one in particular of somebody actually using IPython as a platform for writing a book, and the one I'm thinking of in particular is Bayesian Methods for Hackers, I believe is the title, by Cameron Davidson Pylon.
Yeah, and there's been a number of books or book-like compilations of notebooks. Another example of that is Jose Unpinko started out writing a series of blog posts on doing signal processing with Python, and then he wrote those blog posts as notebooks, and then worked with Springer to turn those notebooks into a traditional Springer book on signal processing. And we're starting to see a number of other books developed in that way. And another exciting development along these lines is that in the last month, O'Reilly Media has built support for notebooks into their publishing platform, which is Atlas. And so O'Reilly authors can now author content that end up in O'Reilly books and online posts as notebooks. and then also distribute that content to users as notebooks. And so that's another example of these computational narratives being authored in different contexts and distributed in different contexts.
That's really very cool. I mean, I think that's something that's been missing. You know, when you look at how younger people just aren't consuming books like a lot of us became used to, sort of coming up in the field now. They're using online resources like blogs and the like. I think one of the things that is causing that, or at least contributing to it, is that lack of immediacy. And I think that having them be able to open up an ebook and bring up an IPython notebook with, if they're trying to learn functional programming or something, you know, a lesson in what are monads and how do I use them, that's interactive, that they can actually play with, I think that could really that could save technical books.
That's something that we're very excited about.
Yeah.
So the IPython notebook seems like a really great tool for educators in advanced fields. Have you seen widespread adoption in this area, and is it a focus for the project?
Yeah, it's definitely a focus for the project, partially because we ourselves are educators, and we end up using the notebook a lot ourselves to teach. So this is one area that we definitely dog food a lot. Just this quarter, actually today, I had the last class for this spring quarter of a computational physics course that I'm teaching here to undergrads. But we're seeing the notebook used for teaching across a wide range of fields, ranging from bioinformatics to physics to data science to computational fluid dynamics. And honestly, at this point, we're having trouble even keeping track of all the different people who are doing this now. And it definitely is a focus for us in terms of development as well. What we're finding is that if you're writing a notebook as a single individual, the workflow is fairly decent now, and the user experience. When you start to work with a large group of people, such as in a classroom, in a collaborative context where you want to distribute materials to the students, you want to gather materials back from the students, there's grading involved. There's still a lot of significant pain points associated with that. And we actually have a new project called NB Grader, as in Notebook Grader, that is designed to help address some of those pain points. And the lead developer of that is a grad student at Berkeley, Jess Hamrick. And she has been working on a course at Berkeley that's been using this since January, and then I've been using it for the last few months. And it definitely helps, but we still have a long ways to go. And there's a lot of interesting work that I think, in terms of really making the notebook practical for teaching, we really need to address these points.
That's very cool. I can totally see that as someone who, to be honest, I'm a really crappy student, just to be perfectly frank about it. And I think that for me, one of the things that made my classroom experience very difficult is that I definitely found there was a real gulf when I sat there in class and just tried to absorb what was being taught to me and what I was being tested on. And so to have the opportunity to have this kind of interactive thing that I can noodle on and really sort of, like, for me, I feel like I have a learning cliff. I have to play with something and poke at it and prod at it and do it. And then all of a sudden I really get it. And it sounds like using a notebook in the classroom context, and even in terms of grading notebooks in a test environment, sounds like something that I could really get behind. That's really exciting.
Yeah.
So GitHub recently added the ability to render notebooks in a repo. Did you work with them to build an integration?
Yeah, though to be fair, the bulk of the hard work was done by the GitHub team, but we did coordinate with them for a long time, and we discussed extensively sort of what would be required for it and how we could help with it. But the vast majority of the work was obviously on their internal architecture. But yes, it was something that we were very keen on seeing happen, and it was wonderful to collaborate with the GitHub team, and they were great. They were great about it.
Yeah, it definitely seems like something that will really drive even more awareness of the presence and capabilities of IPython to people outside of Python who may have never come across it before.
Yeah, we're really excited about that, and I think, for a long time now we have had the NB Viewer site that allows users to see a static HTML rendering of a notebook. And the way NB Viewer works is you can pass it a URL or a GitHub repo and org and view notebooks in that context. And that's been a very popular platform for people to share notebooks. But I think part of the awkwardness is that a lot of people are already on GitHub and they're browsing through repos and notebooks in that context. And it does get to be a little difficult when you click on a notebook on, at least this is how it used to be, click on a notebook on GitHub and all you see is raw JSON data. And so to be able to see on GitHub the rendered notebook is a huge improvement in the user experience. And I think part of what we're hoping is that this drives the discussion about open and reproducible science and journalism. And we're starting to see more and more people who are using GitHub and the notebook as a platform for sharing their content associated with various types of publications in a way that allows users to come on and look at exactly what they've done and reproduce it if they want to.
Very cool. Yeah, there's definitely... I actually was just at the Open Data Science Conference here in Boston this past weekend, and
nice.
There was a lot of discussion around open data and open access to data and exchange of ideas around that. And it's definitely a narrative that I've been seeing pop up in a lot of places that people, even just the average citizen who may not have any interest or facility in technology, are becoming more aware of the data that they produce and what sort of an impact that has on their lives, and also the fact that there's just a general need for them to become a little bit more well-versed in how that data is used and how algorithms are present in everything that they do from when they wake up to when they go to bed, if they live in any sort of a modern and developed nation. So it's very cool to see IPython being used as a tool to help facilitate some of that transparency. So what are some of the most interesting uses of IPython and IPython notebooks that you have seen?
Well, we've tried to sort of enable things with some of our infrastructure, and we collect a gallery. We have a gallery of interesting notebooks where we keep track of some of the interesting things that we see. It's on our wiki. It doesn't have absolutely everything, because it only has it's limited by our own bandwidth, and it's a manually curated directory. But there are things like reproducible, and this is obviously biased by our scientific interest, but things like reproducible academic publications is a section that, as Brian was mentioning already, is of particular interest to us. There is already a couple of dozen scientific papers that you can go to, and some of which are very high-profile scientific papers that you can click on and are accompanied by an entire GitHub repository that has carefully curated collections of notebooks. Some of them have 10 IPython notebooks that you can click through and follow every single step of the process to reproduce every table and figure in the paper, which is really, really beautiful to see scientists sort of saying, this is how I did all of the work in that paper, follow through and get all of my results. You can see notebooks also that have purely educational value, notebooks on topics like signal processing, engineering, linguistics, machine learning, physics, chemistry, math, visualization, whimsical stuff like analyzing soccer data, analyzing Wikipedia data, all kinds of topics. And it's kind of an interesting collection for the public to peruse because you can learn about all kinds of things, and it's a very useful way of seeing the kinds of stuff that people are doing. There are also very notable projects that people have carried that have kind of highly dedicated effort. For example, Lorena Barba, who is an educator that Brian mentioned earlier, recently put together a MOOC that was taught collaboratively. She's a professor in mechanical engineering at George Washington University, and she put together a MOOC taught between herself, a colleague of hers at the University of Southampton, and another colleague of hers in Chile, and the three of them put together a MOOC taught on the Open edX platform. That is a large collection of IPython notebooks on numerical computing, all of it available online, all of it presented on the Open edX platform, and that you can work through as basically and execute the entire set to teach yourself numerical computing with Python end to end. Another highlight that has been extremely popular is Peter Norvig's collection of IPython notebooks. Peter Norvig, who's the director of research at Google, periodically will tackle interesting problems that he finds that he's thinking about. And he will often post his solutions to challenging problems as notebooks. And those notebooks tend to generate a lot of traffic online. We see them. Several of his posts are listed on our gallery, and they're very, very interesting. Recently, he posted one on the traveling salesman problem, for example, which is a fascinating discussion on dynamic programming and how to tackle the traveling salesman program, where he goes through and analyzes the problem very, very carefully. And it's a great example precisely showing why the notebook is a good platform for this, because he builds these little snippets of code where he explains what he's about to do. He builds a tiny little function, then he runs it, he shows the result, then he builds another small function. The code is never very large, and you can follow the discussion and understand his train of thought, and he tackles really, really complex logic and builds it gradually. And then finally, a very recent project that just came online a few days ago from a neuroscientist at Genelia Farm, a rising star neuroscientist in neuroscience called Jeremy Freeman, is at notebooks.codeneuro.org, is a demonstration that uses some of our technology, some of the Docker images that we've built, and a project that comes out of IPython called TempNB that allows you to basically spawn ephemeral notebooks in Docker containers. And Jeremy has put together the TempNB infrastructure together with his libraries that he has built using Spark, the distributed processing framework, together with his code for the analysis of time series data. And he's put this beautiful system called notebooks.codeneuro.org to demonstrate the analysis of time series data taken from, in this case, he has some examples from mice and from zebrafish. And it's an entire demonstration that you can just open and click and load up these Spark containers with code and data, with the entire Spark machinery ready to go, and learn how to use his libraries and run the demonstrations with real data sets, running his code on very interesting scientific data sets. So it's a very relevant and very timely example of using both our tools and the Spark framework, as well as Jeremy's research libraries, to demonstrate it online.
Yeah, that's one of the really kind of incredibly compelling things about IPython Notebook. Even as kind of dovetailing on what Tobias said, for members of the general public, right? Because lately there has been kind of an increasing fascination with consuming data in terms of these infographics that you see in places like Wired and floating around the internet and things like that. And what's kind of amazing about IPython Notebook, even for a layperson, is it's like, going from a photo to virtual reality. It's that kind of a transition, going from these static infographics into an IPython notebook, because the data is live. You can actually sort of slice it, dice it, manipulate it, view it differently, change it. It's a living, breathing thing that you can actually really sort of interact with and move through and, make your own inferences about. It's really kind of, it's really just, to say amazing is not giving it enough praise. It's kind of mind-boggling, actually. So are there any notable projects that use IPython as one of their components?
Yeah, there's actually quite a few, and we have a list on the website. We probably just want to highlight a few right now. One, I want to plug my day job because it's a very interesting scientific research project funded by the Department of Energy. It's a large platform called KBase for computational biology. It's a project led by Lawrence Berkeley National Laboratory, and that is also, which is a large collaboration also with Argonne National Lab, Oak Ridge National Laboratory, and Brookhaven National Lab to build a platform for bioinformatics at scale that is meant to allow biologists to basically analyze large-scale data sets and actually collaborate on large-scale analysis from single-cell organisms to microbial communities, all the way to plants and modeling plants in their environments, and do complex and predictive modeling across data that lives in the entire system, and collaborate on that in the entire interface, and sort of the whole system runs as a highly customized system through IPython. So the what is called the narrative interface is really a very complex and customized IPython interface, and that actually is my main research project in my day job as a scientist at the Department of Energy. And this is a project that has roughly 50 people working full time on it at the Department of Energy. So it's currently in its fourth year. Another project that I want to mention, which is a project that we've collaborated for a long time with, it's called SAGE. It's an open source mathematics project which is written in Python. It was started by a mathematician who used to be a professor at UCSD. When he started it, he's now a professor at the University of Washington in Seattle. SAGE is a project that basically tries to unify many open source math projects, as well as writing its own code, providing a lot of new code in Python, basically for providing a single unified environment for math. It's not so much for numerical computing like NumPy and SciPy and Matplotlib, even though it uses NumPy, SciPy, and Matplotlib. It was really more designed for pure math. It was originally especially more designed for pure mathematics. The creator of SAGE is William Stein. He's a number theorist. And it's a very rich project. It has used IPython since the beginning. The original, William contacted me back in 2005. The terminal console for SAGE has always been a very customized version of IPython, because SAGE has its own custom syntax, which isn't quite Python. He actually pre-parses Python to allow syntax which is in valid Python. And so for him, the fact that IPython allowed a custom parser was perfect, because that's exactly what he wanted to do. Sage has had a notebook since the beginning, and there's been a very kind of playful back and forth between the Sage notebook and the IPython notebook, where we've learned from Sage and Sage has learned from us, and there's been kind of a competitive collaboration where we've learned from each other over the years. But we've collaborated for a long time, and it's been a very fruitful relationship, and we're very good friends with the Sage team. Quantopian is a startup in the Boston area that has built a collaborative platform for financial modeling, where the environment allows people basically to design trading algorithms that run on the Quantopian platform. Quantopian offers people the data and the compute environment, and if people have algorithms that perform well, then they can basically expose those algorithms to others and market them. And that platform is actually built on top of the IPython machinery, running IPython kernels on top of their customized runtime and IPython notebooks. And Quantopian developers actually contribute to the project. They have made fantastic contributions, and they've developed new infrastructure and new machinery for the project, and we have a great relationship with them. Wakari, which is a hosted platform from a company called Continuum Analytics, which is another big player in the scientific computing ecosystem, is a company that offers effectively a completely hosted IPython notebook system that they've offered for a while. We should mention that a lot of the hosted stuff that we've mentioned, such as TempNB before, and many of our services and a lot of the hosted notebooks that you see online, a lot of this is actually backed by the fact that notebooks are available hosted by Rackspace. Many of our services are actually hosted by Rackspace because Rackspace actually develops a lot of our hosts a lot of our services. Rackspace is a company that develops a lot of Python code. One of our core developers is a full-time IPython developer, and he's a full-time Rackspace engineer. And they host a full-time this ephemeral IPython service called TempNB is hosted by Rackspace, and a lot of this infrastructure has been built with Rackspace resources. So these are some of the both open source, government, and commercial projects that in one form or another are building on top of kind of the IPython machinery. I hope that answers the question.
Very much
Yeah,
so.
absolutely does.
That is a pretty impressive list. So definitely a lot of very cool projects for people to check out. There are a couple I've heard of, but a number that I haven't heard of as well. So I guess I know what I'm doing for the rest of the evening. So where do you see Project Jupyter going in the future, and are there any particular new features you'd like to see added?
Yeah, so we have quite ambitious plans for the future. It's been a huge transition for us over the last 12 months, moving from the more narrow focus of just Python to the broader focus of many different languages. And I think one of the biggest challenges we have right now is scaling up our organization from a human perspective. Part of that is attracting new developers, but honestly, part of it is just finding good ways of working with the developers we have. We have enough people now working on the project that it's really challenging to just get all of us working in a productive way. Part of that is working on getting more sustainable funding for the project and also building up the user community in useful ways. In terms of new features that we're looking at, one of the big areas is collaboration. And the biggest feature that we're targeting right now in that front is real-time collaboration, similar to what you get in the context of Google Drive, where multiple people can open up a document at the same time, edit it at the same time, see the edits. And about a year and a half ago now, some engineers at Google approached us with a very nice prototype of this capability that integrated the Google Cloud APIs for collaboration, for document storage with the IPython notebook. And we currently have funding from Google for a postdoc at Berkeley that's helping us build that, basically integrate the work that they did into the Jupyter notebook more officially. And we have some other funding that's going to be coming online to help us with that work as well. A lot of the work that we're looking at over the next, I would say, 2 to 3 years has to do with making our user interface and architecture more modular. We're seeing a lot of people who want to take different components of the notebook and plug it into different contexts. For example, what O'Reilly Media has done is taken the back end, the architecture for running code, but their front end is not the traditional notebook user interface. They have a custom user interface, and they're using part of our JavaScript code, but right now it's a little bit wonky to do that. And so we're spending a lot of time redesigning our user interface to make it more modular. And part of this gets back to the user experience that people have in the notebook right now. The latest version of the notebook also includes the text editor and a terminal. And if you've used that, you'll quickly realize that you might want to have a notebook next to a text editor or next to a tabbed set of terminals. And so we're really pushing the limits on what's possible in the web browser in terms of like paneled layouts, paneled and tabbed layouts. And we're going to be spending a lot of time working on the user interface. A lot of the things we're thinking about have to do with just the general usability and design of the notebook, while the current notebook definitely, I think, eases the pain of a lot of usage cases. there's still a lot of pain points that our users experience every day with our current notebook. And so we're going to spend a lot of time thinking about the usability of it. I don't know, Fernando, I'm probably missing a lot here. We want to jump in on some of this?
No, I think that's a pretty good summary of the highlights.
Well, if we get nothing else, I'm sure people will be absolutely ecstatic with just the features that you listed above, because those are pretty remarkable. Even just the collaborative, real-time editing of a notebook would be pretty amazing for a lot of people, I'm sure.
Actually, one other general area that we see a lot of work on, and that is multi-user deployments of the notebook. We have a new sub-project called Jupyter Hub that adds a multi-user deployment system for the notebook that you can deploy to multiple users on a centralized server or servers. And there are different people using that in different ways. TempNB, which we host, is one example of that. But there's also a lot of other companies, startups, scientific projects, universities leveraging that in different ways. And that's a very active area of development for us.
Maybe two very quick comments. One is that the collaboration actually has multiple angles. The real-time live collaboration is obviously a super important one, but in the context of what Brian just said of Jupyter Hub and these multi-user things, it's actually a much more nuanced problem, because it really is about what does it mean to share projects that involve notebooks when notebooks are executable things. So when you share things on, say, Google Docs, you're just sharing static documents. When you share projects on something like, say, GitHub, you're sharing effectively repos where there's the forking model for repository contributions. Neither of those models quite work well when you actually have executable state. And so there's a lot of nuance that comes into play when you're talking about sharing and collaborating on things that have effectively live executable state in memory. And we haven't completely figured out exactly what that should look like. And so there's a lot of really interesting questions in that, some of which have to do with the version which is about live collaboration, but others go beyond that. And so there's a lot of open questions there that we'll be hammering on over the next few years. And the other point that I wanted to mention is the fact that we're also exploring sort of the questions that go in the direction of what we call sort of software engineering in the notebook, which is a kind of a catchphrase for asking, well, if I'm developing code interactively, but I want to extract maybe something reusable out of it, what would that look like if I don't simply want to, say, copy it out into a file and then turn it just into a library file that I edit in a text editor? If I actually want to maybe keep it in a notebook because I maybe want to be able to go back and still test it interactively. If I want to keep something which remains live because I want to keep it with live examples or something, but I still want to be able to use it as a library, how could we make the notebook environment better support those use cases? And we're not quite sure what that should look like, but we feel that it's our responsibility to sort of explore basically where the notebook creeps a little bit into an IDE. And that may be anathema to some people, but we feel that it's our job to kind of at least push that boundary a little bit.
Yeah. I guess one other area is the Jupyter Notebook supports interactive widgets that allow you to quickly build user interfaces in the notebook documents that are bound to data and objects in the backend kernels. And right now, those user interfaces can be embedded in these notebook documents. And there's a very strong demand for people to be able to develop those user interfaces in a notebook document, but then deploy them in more of a dashboard context where the consumers, the viewers of that content may not want to see any code at all. Maybe all they want to see is a visualization widget that has some sliders and a text box and some checkboxes to specify what algorithms are being run or the options passed to various functions. And so the sort of viewing a notebook as a sort of web application / dashboard type entity that can be deployed and used and reused in different contexts is something that we're thinking a lot about, and there's a lot of interest in.
That is so cool. I mean, just the thought of being able to, like I'm thinking about in industry, in my day-to-day work, I'm relatively new to Python still. I've only been using it for the last 6 or 7 months. And to be able to go to one of the more senior Python devs and say, I'm having trouble with this piece of code, and not having to completely, that they're working from home or something, deal with Skype or whatever the case may be, to be able to share an IPython notebook with them with the code that we can then collaboratively edit and play with and evolve. The opportunities with that are just amazing to me. A few weeks ago, we interviewed Jonathan Slenders, who wrote IPython. I don't know if you folks have encountered that project, but it brings IDE-like capabilities to interactive Python. So if you're at the prompt and you have an object defined, or even just, let's say, like string, you can say string dot and hit tab, and IPython will give you, in your text prompt, a list of completions that you can then choose to invoke the method that you want to invoke. Have you ever considered including this kind of capability in IPython?
There's a thread already with the author on the mailing list this week. So if you check our archives like 2 days ago, there's a thread with him already.
That's great. I wonder if, perhaps conceitedly, I'm wondering if we had some small part in that, because when we interviewed him a few weeks ago, he said he had done a shell, or, he had done some work to allow IPython to be used from within IPython, but the two kernels were incompatible. And I said to him at that point in time, well, it sounds to me like maybe it might be worth talking to those guys, because if you could add this capability to IPython, it would be a really incredible opportunity to improve, to raise the bar once again. That's great. I'm glad it's being thought about and potentially worked on.
No, we're looking into it, and partly because apparently there seems to be really fundamental incompatibilities between Python 3.5 and the library that we need on Windows to support the terminal called PyReadline. Apparently it doesn't work at all on Python 3.5. And apparently the thing that this guy is using may work on Windows out of the box, and it's a pure Python dependency. So we may swap out PyReadline with his thing, and it may actually give us sort of better capabilities than Readline, and actually support a richer experience. Readline, even though it seems to be a simpler dependency because it apparently is shipped, it actually turns out to be a really thorny one, because on OS X it's actually not shipped by default, because it's a fake Readline. You actually get libedit, which has its own set of problems. And on Windows, it doesn't even exist. And what we have is this fake thing called PyReadline, which apparently on 3.5 doesn't even run because of changes that were made to Python. And it's not clear at all that they'll ever be fixed. And so we're actually looking seriously at this thing.
That's great. We don't know what'll happen, but it is a possibility, even for pretty serious technical reasons. Very cool. I wouldn't normally recommend that one set of guests go back and listen to an interview with another set of guests, but you might actually consider giving a listen to our interview with Jonathan, because he kind of explains how some of it works, and it really seems like a very elegantly well thought through implementation. It really, honestly, talking with him really kind of impressed me. So I'm glad to hear that you folks are looking at that, and honestly, it has moved me to go really browse some of his code, because his implementation is very, very interesting. I think it's a nice, in a way, kind of a simple use case for async I/O, a very understandable use case. So it makes for some really interesting code reading.
Glad to hear that.
Yeah, it's very cool having this connection between guests that we have interviewed and are interviewing. So just very cool to see how that comes about in such a broad and welcoming community as Python. So very cool. So what are some of the features of IPython and IPython notebooks that an average user might not know about?
So I'm going to take a little bit of liberty and stretch the definition of the word average.
Absolutely.
And I think the the most important point that in this front is that the architecture that all of these tools are built on is a very open, flexible architecture. And the main building blocks of this, one is the notebook format. So the notebook documents are just a JSON data structure that is stored on the file system. And there's a lot of flexibility around that notebook document. For example, it's really easy to read and write these notebook documents from just about any programming language you could imagine. So, for example, you may have some system that's not the Jupyter Notebook where there's content. It would be, a few lines of code to import and export data from this other system to notebooks. Another example is the network protocol that we have for communicating with kernels, where kernels are the separate process that we start that runs code in a particular language. And there's a lot of people thinking about and working on various, I would say, instantiations of interactive computing systems. And what we're seeing is that the people who take the time to understand our architecture end up getting like superpowers in terms of what they can do in a really short period of time. One example of that is the Atom text editor that came out of GitHub. And recently, someone came up with an Atom plugin called Hydrogen that can run code that you have in the Atom text editor using any of the Jupyter kernels. And the person who developed this took the time to understand our network protocol and how this worked. And what they got from that is that their plugin could all of a sudden run code in any of the approximately 40 languages that we support. And so with a very minimal amount of work compared to what it would take to get something talking to 40 different languages from scratch. And so I think the thing that I would encourage people is that, if you're interested in taking what we've done and using it in different ways, it will be really worth your time to spend the time understanding the different building blocks that we have, the network architecture, and all of this. And there's a lot of potential for reassembling these building blocks in new and interesting ways.
So is there anything in particular that you would like to ask our listeners to help with?
Yeah, obviously, first of all, as every open source project is, join us as kind of as developers. We're an open source project. There's lots of work to do on multiple areas. There's front end work to do in the notebook. On the UI, there's lots of JavaScript work to do. There's also work in the back end. There's Brian already mentioned kind of the document publishing pipeline. The idea of grabbing notebooks and turning them into documents, into websites, into blog posts, into papers, into books. It's a complex pipeline, but it's a really interesting problem that has many different aspects and many targets, and that can be actually a pretty fascinating one. That is somewhat isolated from other aspects of the project, and so it doesn't necessarily intersect with everything else. There's a piece of the project that is somewhat technical but also well isolated, which we haven't talked too much about today, which is all of the parallel computing stuff, a little bit more technical, a little bit more on the scientific end, but also something where people can contribute. But an important and completely different one is that as the community grows and as the project grows, one part that doesn't scale is us. We cannot be everywhere at once. We cannot fly everywhere. We can't be in multiple locations. And so organizing meetups, organizing kind of community events in other places. And one thing that we do have a little bit of is resources. We can, if folks in the community want to organize a meetup and they want to basically run a small community event, we can probably send your way some resources, even some financial resources, to support those events, because we are getting some funding that will allow us to support to the community in that fashion. And that is one way that actually helps us, because it means we don't have to be the ones who do have to get on a plane everywhere. And also be a little bit patient with us in the sense that we know that our documentation in some aspects of the project are not ideal. We are working hard to improve them. We'll get there.
So is there anything that we didn't ask you about or didn't talk about that you would like to bring up?
Yeah, I think we do want to make sure that we credit sort of two aspects of the project. One is the rest of our core developers. Even though Brian and I are here and have spoken today a lot, the project doesn't exist because of us. It really exists because of the rest of our core developers. We have a number of folks who work either full time or nearly full time on the project, and who are absolutely fantastic. And they're really the ones who make all the magic happen. Jonathan Frederick, Kyle Kelly, Min Reagan Kelly, Thomas Kloiver, Matthias Bussonnier, Jess Hamrick, Damian Avila, Sylvain Corley, Jason Grout. Brian, am I forgetting someone?
Some of the folks at Google.
Yes, Kester Tong in particular, Kair Patel. And I may be forgetting Paul Ivanov, who is a little bit less active lately, but was a very active core developer for a long time in the project. And also our institutional sponsors, not just the institutions that I happen to employ, Brian and myself, Cal Poly and UC Berkeley/LBL, but the fact that we have institutions who support our work by funding it. The Alfred P. Sloan Foundation, the Gordon and Betty Moore Foundation, Rackspace in particular has supported us enormously, Microsoft, Google, the Simons Foundation, Continuum Analytics, Enthought. If it weren't for these entities, the project just wouldn't exist. Without their resources, it wouldn't exist. We also want to give a shout out to NumFocus. NumFocus is a 501c3. It is a foundation that actually supports the project in a slightly different manner. It's a foundation that Brian is in the board of directors. I'm an ex-member of the board of directors. I'm actually one of its founders. And it's kind of a parallel entity, if you will, to the Python Software Foundation, but that was created by the scientific computing community to really serve as an umbrella foundation for the open source scientific computing community, to serve the needs of scientific projects that are open source project. And it is the project that hosts the IPython/Jupyter project as a 501c3. And NumFocus is our fiscal sponsor. It's our fiscal home. It's what allows us to receive tax deductible donations, and it's a very important project in the scientific in the open science community. It also hosts. It's not just the Python project. It hosts the Julia project. It hosts the R open science community. It hosts the software carpentry project and the data carpentry project. And without all of these people and these projects, we wouldn't be anywhere.
Yeah,
that's great. It's really heartening to see the amount of community support and contribution that goes into a project like this, and just the amount of time and effort and dedication that everybody puts into it.
That's great. At this point in time, we usually do the picks. So, Tobias, why don't you get us started?
Sure. So, my first pick today is the Dayworld trilogy by Philip Jose Farmer. It's a sci-fi trilogy set in the future where population has grown to the point where it's not possible for everyone to be awake and active at the same time. So people are divided up into specific days of the week during which they're active, and they're put into suspended animation during the rest of the week. And so houses are outfitted with a basement with the suspended animation pods for the various families who live in that household during the different days of the week. And in this world, the most heinous crime is to be what they call a daybreaker, which is somebody who is awake all days of the week. And the protagonist of the story happens to be a daybreaker, and it is just a very compelling and thought-provoking exploration of the effects of population as it expands, and it's just very well written, very entertaining. Highly recommend it. My next pick is a site called readruler.com, which is a site that will link up to your Pocket account and analyze all of the articles, and it allows you to tag them with the length of time that it will take you to read them. And it actually has in the settings, you can go in, it has a reading sample so that you can calculate your reading speed so that it can more accurately tag the various articles. So I have a large number of articles in my Pocket account that I have been meaning to get to, and I found that this is a really interesting way of being able to pick off the low-hanging fruit and see, okay, these are the very short articles without necessarily having to go through and look at them individually. And I am going to leave it at that for today. So, Chris, please take it away. Cool.
I'm going to commit a little bit of heresy here, and on a Python podcast, I'm going to recommend a Ruby thing. I'm going to recommend it because it is so good that I think that you can learn something about programming by watching these. It doesn't matter what programming language you're in. Yes, they're oriented towards Ruby, but the fundamental concepts that Avdi puts forth are really interesting, could be useful to anyone, I think. There's a series of screencasts called Ruby Tapas, and what's amazing about them, I know everybody and their uncle has started producing paid screencasts these days, is they are the most perfect exemplar, from my perspective, of just little itsy-bitsy, exactly what they say, tapas, little tidbits, little 3 to 5 minute videos that show you one concept and only one concept and do it really clearly, really in a really straightforward way with a little bit of humor. They're phenomenal. I still subscribe to them, even though I don't use Ruby much anymore. I've kind of transitioned to Python in my day job. I still write Ruby with Chef, but I still keep giving Avdi my money because they're just that good. So there. The next pick that I have, we've mentioned her, or rather I've mentioned her a bunch on the podcast, but one of our readers mentioned that I had not actually picked her work yet, and so it hadn't been in our show notes. I just wanted to pick codenewbies.com. It's a site and associated gaggle of communities put together by Saran Yitbarek, who we hope to have on our show at some point in the future. She is a one-woman dynamo when it comes to helping people learn how to code and get their first job in the technology field. Really, it's an amazing resource, both obviously for people who are trying to learn how to code, and even from my perspective, even if you're an old hand, it's a really great community. Her podcast is amazing. Her forums are great. You can help new people out and probably learn something while you're doing it. It's definitely worth, if not looking into for your own sake, it's definitely worth being aware of just because it's amazing work that she's doing and deserves recognition. And for my last pick, I'm going to pick a Twitter client for Macs called Tweetbot. And it's one of those pieces of software that really just hits the spot. The UI is beautiful. It is featureful. It does everything that I need it to do and more. It's very intuitive. The authors are very responsive. It works great on the Mac and on my iOS devices and syncs my tweets in between so that, I can stop reading at work or at home and then start reading on the subway, and it keeps my place. It's well worth its weight in gold, worth its price. I forget how much it is, but it's pretty cheap. So yeah, that. And I think that's about it for me this week. Brian, why don't you give us your picks?
Yeah, so there's actually 2 books that I'm really enjoying right now. The first is a new book out by Joel Gruss. I think that's how you say his last name. Apologies if not. And in the book, it's an O'Reilly book called Data Science from Scratch. And part of what's fantastic about Python is that there's all of these libraries for doing data science, such as pandas, stats models, scikit-learn. And those libraries are great, but I think they have a weakness in that they end up being very easy to use black boxes that don't necessarily help someone who's learning about data science to understand what the algorithms are actually doing. And I think getting that deeper knowledge of what's actually going on is really important. And the philosophy of data science from scratch is that he walks through how to implement a lot of the core algorithms in data science from scratch without relying on scikit-learn, for example, or pandas. And it's at a really nice level where someone who knows the basics of Python and NumPy and Matplotlib is going to be able to pick this up and learn a lot about the internal details. And so I've been really enjoying that, especially as I think about how to teach data science to undergrads. And then the second book is William Cleveland's Elements of Graphing Data. I got this a few months ago and have been spending time with it. And it's just an extremely practical, nice book about visualizations and plotting. And it's a type of book that, I spend 5 minutes with it, and I feel like a lot of things that I had fuzzy thinking about in terms of visualization all of a sudden became crystal clear. Like simple questions of should the tick marks on your axes be pointing inside or outwards? And he says, well, you have data on the inside of the frame, and if your tick marks point inwards, there's a good chance that the data is going to overlap the tick marks, making it difficult to see them, so they should point outwards. And obviously it's not a universal rule that you always must follow, but it's a very practical way of thinking about choices like that otherwise, in the past, I think I would have approached from a more of a visual aesthetic perspective. And so it's a wonderful book.
Yeah, I guess I'm kind of a little bit less pragmatic right now of a mindset in terms of books. A book that has resonated a lot lately with me is Republic Lost from Lawrence Lessig. It's really a fantastic read, I think, for today's world from Lessig. Lessig kind of took a step back away from this. A lot of his work had been about code and the culture of the internet, and this is really a book about Congress and about the modern world of politics. And what I find fascinating about it is that it's a book about how sort of how humans with good intentions and fundamentally sort of in many ways trying to do the right thing can do things that are so problematic to society. And I think it's a book that has very enlightening lessons, I think, to teach many of us, and asks really important questions about society. And the other one is actually an author more than a specific book from Colombia. I've heard a lot of in the geek world, because I'm a Colombian. In the geek world, I hear a lot of people are in the U.S. like actually a Latin American author called Jorge Luis Borges, because a lot of his poetry and a lot of his short stories have a very kind of logical, mathematical bent to it. And Colombia has an author that, in my mind, who is much less well known than Borges, but who I would recommend because there's echoes of Borges in him, but with a little bit of a Garcia Marquez twist. And his name is Álvaro Mutis, and he has both short stories and poetry that has kind of some echoes of Borges with a lot of really crazy kind of a character who is a wanderer, traveler through the jungles of Colombia, who is a very interesting character called Macrol el Gaviero, and I would highly recommend his novels to people who have kind of a love for Borges's logical mindset, but at the same time who are interested in adventure. So again, Álvaro Mutis, he is available actually in English, but he's not very well known, and so I figured I would make some kind of slightly oddball picks.
Great. Well, thank you very much, and thank you both for taking the time to come on the show with us today. So for anybody who is interested in following you and the things that you guys are doing, what would be the best way to do that?
Twitter or email in my case?
Yeah, honestly, Twitter these days has become an invaluable way where we keep in touch with users, we hear about things, so that's a great place to go for that.
Okay.
So what Twitter handles should users be following to do that?
So the Twitter handle for Jupyter is @ProjectJupyter. And the one for IPython is IPythonDev. And then my Twitter handle is EllisonBG. And Fernando, yours is?
At fperez_org.
Excellent. So, again, thank you very much for coming on the show. It has been a wonderful discussion, and I learned a whole lot about the IPython and Jupyter projects that I never knew before, and I definitely think I have a lot of things to read up about. So, thank you very much.
Me too, and I also just want to really quickly, in addition to thanking Brian and Fernando, want to thank Travis Oliphant for actually hooking us up with these two guys, because the IPython notebook project is one of the first things that when Tobias and I were saying, hey, we should do a Python podcast, we both sort of batted around as, in my opinion, this is one of the coolest things in the Python ecosystem. So we really wanted to talk to you from the very beginning. And once again, thank you, Travis, for hooking us up.
Well, thanks for having us. We really appreciate it. And obviously, Travis is another one of our long-standing friends, supporters, colleagues, and sort of heroes of our community. So thanks, Travis.
Yeah, thanks so much for having us on. It's been a pleasure.